All right, so we were doing some bell work before today's notes in 9-4. So we did the trick starting at a corner, right, up, down, right, right, and that's that proportion, and then you can look at that work there. Okay, next student, where are we at? Kayla. Which one is this one? And hopefully in the last one, sorry, Kayla, I'll give you a chance to think. Hopefully in this last one,
It's not presenting anymore.
what? What happened? That makes me sad. I didn't change anything. Maybe I hit the wrong thing. That's possible. Thank you. Oh, then there we go. Good. Everyone said that up there. You're not sharing anymore. Sharing is caring. Okay. So I must have hit the wrong button here. Stop sharing or hide. Maybe I hit stop sharing instead of that. Hopefully I'm still let's see, still taping. This is so embarrassing. Okay. All right. I erased something here, hit the back button. Good. All right, hopefully you knew in this one that this length right here was attached to this altitude. When it's on the inside, make that assumption. If you thought it was attached to this, then maybe that's, could have been a problem, but it's attached to that. But this one's very specific, Kayla. This one is on this leg. So where do I start? In the middle for the trick or on the outsides?
The middle.
You are correct. So I'm going to start in the middle and then set up our proportion. What goes up in the top?
85.
Good. You have to go this way because the leg that's given is attached to the 85 or adjacent to it. Then over what?
11 square root 85.
Nice. Because we go this way next. Then what on this next fraction?
11 square root 85.
Nice. Just the double checking that we got that trick down. And then what? Ooh, this
85
is
plus x.
nice. Good. It's the whole hypotenuse. If you remember, in the grand scheme of things, we're saying this triangle is similar to the big triangle. So that's why it's that whole 85 plus x. 85 plus x is the hypotenuse of the blue. 11 root 85 is the hypotenuse of the yellow. So again, remember we talked about this is because of similar triangles secretly with this trick. So I like actually reiterating that. Hey, in the chat, 85 times 85. Please helping a fella out, that fella being me. And hopefully you understand that I'm distributing this. We're in honors. We should be able to, save some steps. Is anyone verify the 7225? Okay, good. Got a couple verifications there. Then I'll do this. 11 times 11 is 121. Root 85 times root 85 is 85. Now in the chat, can you tell me what 121 times 85 is? 121 times 85, yes. And we're going to go ahead. You just said you'd write all your steps, Mr. Samulus. But in this case, I think we'd be all right. You could type in 11 times or 121 times 85. Good. 10,285. Then subtract 7225 from that and write that in the chat for me. This is the kind of stuff I would not mind you skipping. I think you could multiply and then subtract on your calculator and write the next thing. Good. 3060. See a couple people writing that. 345. Much appreciated. Then divide by 85. And what's x equal to? 36, a bunch of people. Again, much appreciated on the chat. That's amazing. And then more people writing that down means we're pretty sure on that 36. Okay. Now, before I show the beginning of the next notes, I think this is a good idea, especially if you have time to do this today. I'm going to zoom in like right here. Maybe a separate sheet of paper, to get ready for. This is like a study tactic too. It's not only so that you have something useful in front of you, but also in doing this, you're actually ingraining these in your mind even more. In a separate sheet of paper, I might segment it out into sections and figure out how many after today. But I think we have our 2 theorems from yesterday. So you'd put that here and here. And then I will have 4 of them here today. And then having them all in one spot to look at. But the fact of creating that sheet is actually a study tactic. You reaffirm these ideas and put them there. So in this little thing, I would put maybe something simple like this. So I have a right triangle, and then I drop an altitude. So because what we're going to have is a bunch of little different drawings on the quiz, and you got to look at the drawing and say, which theorem is this emulating? So this is the one where I have a bunch of right triangles. And then I might even make it as simple as this, x, y, z. And then I would put trick, 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 trick. And what that means is x over y equals y over z, where y is the geometric mean. Just something simple, something basic, something in your own words to get you to understand. When I see this drawing, this is what I do. All right, kind of idea. And I think that's a smart memorization trick or a tactic for studying. Because then once you create that thing, many will find you don't even need that sheet anymore. Just by the creation of it, your mind is already separating these things in your head. Okay, so here's a couple more. Today is not near as bad. It's actually pretty simple stuff here today. Where are we at? Kayla, you went, right?
Yeah.
Yeah, okay. So Ethan, you're next. All right, but we won't bother you until we actually get to a variable question. So here's our next one. The angle bisector proportional side theorem. A bisector of an angle in a triangle. Stop. We're saying AD is a bisector, so the markings of this would look like this. And also taking my time, it gives you time to write the drawing and write the sentence, but then start marking up your drawing appropriately. So the bisector of an angle of a triangle divides the opposite side into two segments. So again, understand what that means. This is segment 1. This is segment 2. But I'm going to use the names of the sides, BD and DC, instead of what I did yesterday. Whose lengths are proportional to the sides adjacent to the bisected angle. What adjacent means is right next to or connected to or helps make the angle measure in question. So here's what we need to do. We could set up a whole bunch of different things with this, but I'm going to stick with the sentence first. Specifically with the sentence, the segments created by the bisector are proportional. So segment 1 divided by segment 2. Now notice which way I went. This is the only thing that people last hour screwed up when I asked them the questions. I don't see how we could mess this up. I went left to right. I did segment 1 divided by segment 2. Since that's the case, we have to go left to right, comparing the legs proportionally. AB proportional to AC. Okay? So segment 1 to segment 2, left to right. I must go left to right. Leg 1, leg 2, I guess is what we could call those. What else could we do? You could do something completely different here and still be okay. I could go right to left over right to left. I think we get that. I could do segment 2 over segment 1 equals CA over AB or AC over AB. But I also could do this. I could stay on the left side and go AB over BD as long as I go top to bottom on the right side. AC over DC. The reason is, look at what happens when we cross multiply each one of these. AB times DC, well, we got AB times DC up here in this proportion. And then down in this top proportion, BD times AC, we still have BD times AC in this proportion. Another reason why there's many different ways you could write this. The only thing you could screw up is order, right? And that's what I had someone consistently do last hour, and I don't know how I can help that person. All right, so hopefully we can make sure we understand that. Whole bunch of different ways. Very tough to mess this up. So I think I've stalled enough where you had enough time to write this. On your own time, make that cheat sheet thing. Or you can start making it now, and then you use that, for your homework, so to speak. And I'm going to skip this one. It's not really a big deal. It's just it's a word problem with streets and an angle bisector. I think we're good on this one. We're going to go right to this. And Ethan, this is just a are you paying attention thing. So get your mic on, but I'll ask you specifically here shortly. So CD bisects angle C. And go ahead, Ethan, and everyone else, write this down as we go. I always like marking those as equal angles, then noting that that's a bisector. But also we might not have the words there. It might be a section that says find X, and then this is one of those many questions, and then you see this drawing. That's what I mean about your cheat sheet. Recognize that drawing and recognize, wait, what do I have here? Oh, I have the angle bisector theorem, right? Trying to climb into your head here, thinking about the future, which is your test coming up. Quiz, call it quiz. All right, Ethan, I think I gave you enough time for stalling. You know what I'm going to call BD, though? I'm going to call it X just to make this easier. So, Ethan, what do we got as a correct proportion we could set up? Ethan Rudman, we're going. Oh, I just said your name on the internet, but we weren't getting the answer, and so I had to.
Sorry, I didn't know which. Ethan.
Well, we're going alphabetically backwards, so yeah, okay. You're in the later end.
So BD over.
Well, no, put it with numbers and letters, and change BD to X. That's our unknown.
So you have X over. What would you put as DC then?
It's not part of this, actually. All right, so DC is not part of that. So pick a number that you see here. So DC is not part of the proportion that's set up. Notice in our theorem, the angle bisector itself is not part of any of this proportion. It was this over this equals this over this, or those other two sides. So follow along that theorem and see what number you want to put underneath that. You have two possibilities here.
Is it 30?
Okay, well then you're stuck. If you did X over 30, what does that equal over on the other side?
I don't know.
Okay, it's this over this. So what does that become?
8 over 24.
And we'll come back to you. Okay, so we are going to go ahead and solve this. I won't ask anyone. Well, actually, I'll ask in the chat, which doesn't count for the never mind. This is easy. 24x equals 240. Divide by 24. I can do that. That's actually x equals 10. All right, Ethan, we'll give it another try. Okay, so now let's look at our next question, and it might just be a tougher solve that we can move on. Hey, then I'm going to offer a chat question that could skip you if you want to answer it ahead of time here, but wait for that. Okay, I was stalling. Actually, I could leave that math there for this one. Okay, actually, let's move on. Brian, hey, Brian, nice to meet you. It's the first time I get to talk to you. This is a thing I do. All right, so Brian, first of all, set up a correct proportion out of this, but let me mark this first and give you a chance to write this down. So take a breath for a second. So this is an angle bisector. All right, so just give me a true proportion based off of what you just saw in the last example, in addition to the notes for this. Go ahead, Brian.
In the numerator, you could do 2x plus 1.
2x plus 1, got it? Over
3.
Okay, now you're stuck. What does that equal?
Then that would be x over 2.
You did the old flipperoo. Why'd you go top to bottom and then go bottom to top? That's the only thing that's going to go wrong with this. You got to stay with the correct order. So readjust, and what is it actually?
2 over x.
That's a must. Once you establish the first order, you must follow that order in these theorems. And actually, all the theorems today kind of work the same way. So this is what we got to get going on that. All right, here we go. Get ready in the chat, and then this will cancel you for having to answer a question later. So no one, Kayla, Sydney, Patrick, Brian, don't answer these. Ethan, you can if you're a good factor. Hint, hint. When I cross multiply, I distribute the x. We should be able to handle that. 2x squared plus 1x equals 6. You can't solve that right now. When you have an x squared and an x, you must solve by factoring. The first person in the chat that can give me the correct factorization of this, you will not have to answer a question later. So I'll wait. And then if some two people go like almost at the same time as I look at this, then I'll count two of you. So the speed of light, if your internet's good and plus. Oh no, Matt, what's x times x? Good FOILers are good factors. X times x is not 2x squared. Right? That's you're doing a trick and you didn't do all the steps of the trick. That's the problems with tricks. You have to know that this is an unfoil and your answer must make sense. Ooh, it went too fast. Cecilia and Sebastian. Oh no, Cecilia, there's different answers there, right? So sorry, Cecilia, just made one little mistake on the signs. Sebastian, we're gonna give it to you. So Sebastian, you're out. Remind me that if I get to you and I start making the answer a question. Good job. So that's the thing, Matt. You gotta make sure that your answer foils to be the question. So good FOILers, good factors. I would not do a 4-step process on this. I would know 2x squared is 2x and x, and then I'd start just unfoiling, trying to just guess and check. So 2x times x is 2x squared, negative 3 times 2 is negative 6. That's where my guess and checking is. Where does the 3 and the 2 go? And who's negative? That is the middle term. 4x minus 3x. I still believe there's people. I have people in CAT that still can't foil. I don't know how they survive to CAT when they still can't do that basic foiling idea and understand that factoring is the reverse of that. It is a problem, right? And that comes from, if you're still not able to factor, it's on you and you need to do something in order to get it figured out. Hey, just go in Google and put factoring videos and just watch somebody else with a nice voice show some factoring skills, but they'll probably show you some tricks, and those are sometimes a problem. Hey, so Brian, you're done, right? You, well, I had to make an adjustment on you, but I guess we'll call it a day for you since that was your first time in front of the class, new this year.
Thanks.
Yeah, you're welcome. Thanks for the thank you. But, well, Brian, let me ask you this though. You got a problem with x equals -2 in geometry? I mean, x equals -2, so that's the length of that side, -2 inches. Does that make any sense?
No.
No, it doesn't. This is called an extraneous solution in geometry. Geometry can't have negative lengths, so we do have to cross that off. Okay, so make sure you do that at the end, and now you're officially done for the day. All right, so
Okay.
Peyton, be ready. I don't think I need to do that one. It's a little overdone, so I'm going to go to this one. So Peyton and everyone else will give you a chance to write this down before we move on. Okay, fine. AD bisects. Great. The pens like tap in and out again. Oh, okay. I'll help you out on this, Peyton. This is a little bit rough, though. So we do know we have a proportionality, but they give us this thing. Now, we did have this happen before. I'm going to tell you what you do on this. This is just some cryptic jerk math teacher trying to make the students think about what to do here. So I know AC plus AB equals 36 together. So what I'm going to do is make AC X. I don't know it, Peyton. If that is X, what is AB in terms of X, knowing what we know up in the given there? What is this in terms of X? We had something similar to this earlier in the bell work, but this is maybe a little bit different. No, I think it's not any different. So if they add up to 36 and one of them's X, what's the other one have to be?
Would it be something like X plus AB or something?
No.
Or 36
Yeah, there, go ahead, say it. Go ahead.
36 minus X?
Did you get that on your own or did someone text you?
They didn't put the thing that I said, though.
Okay, all right. Oh, and then Alessandra, she tried to help you on the chat. But Alessandra, a little switch on that. It can't be negative. X minus 36 would give you a negative side value. So again, it goes to the point of if AC was 10, then everyone could tell me that BC is 26 if they add up to 36. 36 minus 10. So that's what it would end up being. Now, Peyton, I think you should be able to do this. because we kind of had a little stumble on there. What would be a correct proportion now that we have this? Got a lot of choices, so it's set up a proportion that's true.
Could it be 7/14?
That's fine as long as you go in the same order. So you went like this.
Yeah, and then could it be x/36 minus x?
You are correct. That's one possibility. This way to this way. Order. That's why I don't think this is difficult. All right, and then when we cross multiply, I think I could do this one. 210. I think it's 252. Just put in the chat if I'm wrong. And then that equals 14x. And then I would add 7x just for purposes of making this go a little fast here. And then divide by 21. I think that's 12 because 21 goes into 210 10 times. So then I just added 2 more 21s. So I think x equals 12. If I'm wrong, stop me or say so in the chat. Okay, so after this, I hope we can solve. And again, you're a charlatan. Look up that word. You're trying to, pretend, you're just not doing your work and you're only fooling yourself and nobody else if you don't show a couple steps of solving. No excuses for it whatsoever. Hey, did I say good morning? I'm sorry if I'm being crass now and I didn't start with a positive. Good morning, everybody. Good morning, Mr. Samuel. All right, Emily, Ann. Oh, thanks. Peyton gave me a thumbs up. I'll count that as a good morning, Peyton. All right. Oh, Ethan, and then be ready. We're going to have Emily, Ann go, then we're going to go back to you. Okay, but now we got a different one. Ooh, the side splitter theorem. Ouch. Okay, triangle proportionality theorem. And then I have something to add to this that I'll do on my own. But the theorem is pretty straightforward, and it's kind of similar what you can do on this one compared to our last theorem. That's why these are not really that bad. If a line parallel to one side of a triangle, well, here we go. If a line parallel to one side of a triangle, so here's what we're saying. Here's a side of a triangle, and then we put another segment or line in the middle of this, and those two are parallel. So let's go ahead and mark that with our first sentence there. Intersects the other two sides, then it divides the two sides proportionally. So here we go. How do I set that up? So what it does is it divides these sides proportionally. This is what we can write. We can write a whole bunch of stuff. So I'm going to go like this first. AD over DB. So that's the that side that's cut up into those two segments. So AD over DB, that would equal, I think everyone can figure this out, AE over EC. All right? Well, what else I could have drawn is this over this equals this over this. Or I could reverse the arrows and go right to left instead of left to right. So I could have said AD over AE. Left to right equals bottom left to right. Okay, and I could do two more different ones. I could change the order that I do these because it doesn't matter. When you cross multiply, the same things are getting multiplied together. AD times EC, DB times AE. And as long as that is true, then the proportion holds and we'll be good to go. Now, I guess I'm going to wait. I'll wait on the next part that this makes up and what else is true because of this. So Emily Ann, you ready? I love that confidence. Okay, Emily Ann, you are going to find X. And then what I'm going to open up is how can I find Y after this? You're going to find X first and concentrate on that. So based off of what you just said, Emily, give me a true proportion.
18 over x equals 9/4.
Ain't no thing. Chicken wing. And then you just go ahead and cross multiply. That's why this is not a major deal, man. 46 8, 10, 32, 72. 9 times 8 is 72. Okay, but then here's how you find y, and here's what happens. I'm going to go back up to my theorem and add to it. The theorem actually creates something extra. It's really not part of the theorem, but it actually does create something. And I'm going to actually go back up to this. Well, I'm going to stay here. You know what happened now? This triangle, because those lines are parallel, is now similar to this big triangle. And it's similar by side angle side, because these two triangles share that angle. So that angle is equal to itself, both in the yellow and the blue. And now, since I found x to be 8, you're going to find out that 8 over 18 plus 8 is proportional to 9 over 9 plus 4. So, an added component to this theorem, what this creates, now triangle A to D to E is now similar to triangle the big one, A to B to C. So I'm going to mark that again in this. It creates a third or a second situation, this side splitter theorem. So what's true then is you got to be careful. In the small triangle, AD goes with the full side A to B. That's what you got to be careful in doing this. And that is equal to AE, small triangle, goes with big side all the way through A to C. So you got to be careful. You got to use the full blue side for similar triangles here. So it's a little different than the side splitter theorem. But now what that incorporates is, now I can get these two sides that are parallel to each other, that relationship. Now I can find DE and BC using similar triangles. Do understand that this is just an added component that the side splitter theorem creates. So it is related to the side splitter theorem, but not completely and totally. All right, Ethan, I'll give you a break. I'll answer this one then. How do I find 12, or how do I find y using 12? This is not correct. You don't use 9 over 4. You got to use 9 over 13, because 9, the side in the yellow triangle, is related to 13 in the blue triangle. So 9 over 13 equals small to big 12 over y. Or you could go to the other side. 18 over 26 equals 12 over y. It's one or the other. 18 plus 8 is 26. Then you get 9y equals 144 plus another 12, 154, 156. I can't think. In the chat, just anyone? It doesn't count as you're going, but what's 156 divided by 9? I should be able to figure it out. I just don't want to think. No one's going to help me? Oh, I think it's a decimal. Anyone? Bueller? 17.3 repeating. You guys probably never saw Ferris Bueller. How many people have seen Ferris Bueller's Day Off? Raise your hand. Nice. Cecilia, good. Couple others, good. All right. Really positive about school of that movie. Anyway. All right, Ethan. Set up a correct proportion on this one.
Is it x over 5 equals 5x over 9?
You did it again, Ethan. You went x over 5. You went bottom to top, but then you went top to bottom. No, so what is it again? So x over 5 is what?
9 over 5x.
Oh, okay. Hold on. I got something in the chat there. 9 over 5. Ooh, the chat's going crazy right now. Students are chatting. Okay, so you use the number 13 when it should be 18, right? No, because you add 9 and 4. Oh, yeah, okay. Yeah, so I was using this side. So 9 over the whole side 13 equals 12 over y. If you use this side, this is also 18 over 26. 18 over 26 also equals 12 over y, and you would get the same answer. So saw some chat going on there. Okay, good. All right, so you got that. Ethan, go ahead and turn off your mic. Just go in order, Ethan. Don't mess this up. These are pretty straightforward here. So whatever order you choose on the first fraction, you got to stay with that order in the second one. And all of this today, actually, these different formulas, theorems. I keep saying formulas. I don't know why. All right, cross multiply, x squared equals 9. And then, as an algebra student, I'd appreciate writing the plus minus, but then setting off to the side that geometry, we only do the plus because it's side measures. Right, Brian? New guy? All right, Alessandra, you're next. Let's see if we can jump down to this one. I'll give you a chance, though. I know sometimes you're trying to take the notes, looking up, down. It does take some time. Right? And I put that in number 6 in blue just to show you that, okay, now we can continue and do similar triangles to find that. Number 7, I didn't do anything about the bottom sides here. Just be careful in dealing with the bottom sides. You got to use the full side similar triangle situation. So there is a nice question in the book that tells you a question like this, find X, Y, and Z. There's 3 parts you got to find. You definitely have to find a specific part first, and then it snowballs into being able to find the other one. So hopefully in the homework you can handle that. Okay, so where are we at? Alessandra? We got one of these questions again. We got that whole marking of a side there. So we got the parallel line, so that's good. But what is this side in terms of x? What is AB in terms of x?
It would be x 24 minus x.
Good save. You are correct. And I'll move on because I want to get more people. And you know what I would do, Alessandra? I'd get rid of this. This is now a distractor. I'm not using that. Okay, but I used it in order to say what AB is. And then we'll move on to John. What is a correct proportion here?
24 minus x over x equals 20 over 12.
Nice. You're done for the day. You've used your voice. All right, and then I just remember this from last hour, but it actually isn't bad. 24 times 12 is 12 times 12 times 2. So 144 times 2. I don't know if anyone heard that. I like to do mental math just to keep my brain going mathematically. Some people use that calculator too much, and that's why to this day you're probably bad at factoring because you're bad at like getting numbers multiplied and added. And that numeracy, that is actually a word. Numeracy is similar to literacy in English. Literacy, we're good at reading and good with words. Numeracy, good with numbers. A calculator has destroyed numeracy. And then it's that part of the brain and for math. Oh, just be quiet, Mr. S. What's 288 divided by 32? Now you can say, you find out. You're numerate. All right. Ooh, which one is it? 9 or 8? There's a fight in the chat. Don't feel bad, whoever was incorrect. Is it 9? 9, 9? Oh, Cecilia, she made the corrections here. So I'm assuming it's 9. I'm not going to my calculator. I'm trusting you guys. All right. I think we're done with that one. Look at this next theorem. You almost barely have to write it because it's very much like this one. I just didn't want to do that. It's a little redundant at this point. Oh, no, actually, I'm wrong. I keep forgetting about this. Go ahead and write this as the converse. This is just a different way of asking a question about this theorem. What converse means is switching the if and the then, all right? And that makes a theorem a theorem. If the if-then statement's true, the converse should also be true. Actually, a whole bunch of other things. There's something called a contrapositive and all this other stuff. We're not going to worry about that this year. So all it's saying is if a line divides sides of a triangle proportionally, so if AD over DB is congruent to AE over EC, the only way that could happen is if these sides are parallel. Then DE must be parallel to BC. It's just the reverse, which is called the converse of the theorem we just went through. So we'll show you how you prove that. Where are we at? Carolina. And then we have to skip Sebastian. Sebastian got that factoring. You've been a good factorer all year long. That thing comes back. And now I know you don't do any tricks, Sebastian, right? You just unfoil, correct? Yep, shaking your head. It's the way to be, man. Okay, so Carolina, just stalling for people to write this down. So here's how this will be worded. Use the given information, determine whether BE is parallel to CD. What are you going to do to see if this is true or not, Carolina?
Would you set up a proportion?
Yep.
I did 21/7 equals 18/16.
Now I'm not correcting you. Remember my made up symbol, question mark equal. That's what you're questioning. Are these equal or not? So I like the question mark equal sign. You'll probably never see that anywhere else. It's a Mr. Samuel symbol. But is it true, Carolina? Are these true or are these equal? I mean,
Yeah.
yeah, they're 3. 3 equals 3. Check baby, check baby. 1, 2, 3. We can say BE then is parallel to CD. And that is the answer to the question that you circle. So understand what we did before. We were solving for x because we knew the lines were parallel. If the sides are proportional, then the lines are parallel. And that's the proof of it. I won't bother any student on this one. I don't care which way you go. If we go this way, 34/16, does that equal this way, 35/15? That's why I don't think this should be a problem, just getting your order correctly. You don't cross multiply on this, although you could, and the cross multiplication will be false. Oh, I forget. I did this last hour, 16, 32, 32. So this is 2. I'm going to do this as a fraction. 16 goes into 34, goes into 32 with 2 left over. 2/16 is 1/8. You'll get the decimal that represents 1/8. 15 goes into 30 2 times with 5/15 left over. These are not equal. Question mark, they are not equal, so therefore not parallel. Not 11, what does that mean? All right, you know that's the parallel symbol, I'm just being lazy. Okay, so they're not parallel in this case. All right, the next theorem is almost exactly this past one, except there is not a triangle. So this is again why I don't think this is a big deal. All these work very similar. It's the order that you need to hold true. Okay, and that's why we cover this one. This is almost the same thing, except I don't have a triangle completed. So it's not really a big deal, all right? So without having a triangle completed, you need 3 parallel lines, not just 2. But really what it does is it creates the same situation. So if 3 parallel lines intersect 2 transversals, then they divide those transversals proportionally. So again, I could have 4, 5, 6 different proportions I could set up. But we'll set up the basic ones. AB over BC. What did I do here? I went this one over this one. So that must equal this one over this one. Ain't no thing, chicken wings. And then I know I could have righted, I don't know what the correct English is. I could say this over this. AB over DE. Top over top in the same order. Bottom over bottom. BC over EF. My pen keeps going in, out, in, out. BC over EF. If you look at the cross multiplies, AB still gets hit by EF, BC still gets hit by DE. So that's why we know this is true. One thing I should be showing too, it kind of is related to those similar triangle things. You could do this, AB over this whole side. You know, that's a new thing, and I could have done that in the previous questions as well, but that is true. If all these little parts are proportional, then the sum of those parts would be proportional with some of those other parts. So one other, I didn't show this in the other hour, you don't necessarily need, to do this. We could just take part over part equals part over part, but this is certainly true. And then that would be proportional to this over this. So just to keep that in mind, top part over whole equals top part over whole is another possibility, because all those little parts are proportional. So the sum of those parts are proportional. All right, so just keep that in mind, a little added thing, but really the top one or one of the top 2 is all you'll really need. So just to check in if you're paying attention, we're on Adrian. What would I set up as a proportion then with this given?
So you could do 21 over x
Okay.
is equal
Yep. Go. Sorry.
is equal to 9 over
Just
15.
keep your order. Okay. As long as you do this, you're stuck now that you have to do this. So your first
Yeah.
thing is a choice, but your second one is not. Okay. Good. Turn it off. 9x equals, just seeing if we're paying attention. Okay. Oh, 210 and then half of 210. 105. 210. Is that 315? Or am I way off? I don't know. That was maybe too fast. Anyone check 21 times 15? Try to do some mental math on that one. Nice. Divide that by 9 then. I can't think of that one either. So 35. I'm gonna agree with that. Good. A couple people wrote 35. And they get a thumbs up on your pictures. Okay, next, Lauren. I like doing this too because then at the end I write my attendance at the end, and then I could just say, hey, I talked to that person. I know they were in class. So Lauren, hey, hold on, Lauren. Are these marked as parallel? Yes or no?
No.
No. I have a question though. These angles are marked as equal. I'll give you a multiple choice. What are those angles with the transversal thing cut by parallel lines? Are they alternate interior angles? Are they corresponding angles? Are they alternate exterior angles? Or same side interior? Which one are they? You are right, and you're done. Lord Evan, you're next. Since Evan and everyone else, these corresponding angles, that is actually a marking that those are congruent. This is like the converse of that, parallel lines cut by a transversal. If they're parallel, then corresponding angles are equal. Switch it. If the corresponding angles are equal, then the lines are parallel. So that's why this is marked this way. You're supposed to kind of know that. Okay, Evan, set up a correct proportion.
2 over x plus 5 is equal to 3 over 27.
And then you know how to, we've cross multiplied enough. Let's move on. All right, Miranda. Okay, you can solve that later. I'm good with that. Let's see if this one becomes a little bit more complicated. So Miranda, just to check, what would the proportion be for this one? Because these are already marked as parallel, so we're good to go.
Okay, it would be 4 over 18, I believe.
Sure. Then you're stuck.
And then x plus 2 over 2x plus 19.
And then you'd cross multiply, and this one I'll go through. Cross multiply, that's 8x plus, oh, I got this one, 40, and then 4 times 9 is 36. 76, put in the chat only if I'm wrong, or stop me. And then 18x plus 36. So I'm doing the distribution. You should be able to handle that in this honors class. Subtract 8x, because I want x to be positive. Therefore, I'll subtract 36 from both sides. And in honors, we should be able to do these basic equation solvings. And if this is the problem and we can't do these things, well, then that we need to practice. That's all I can say. Right? It should not be what's stumbling us in this class, the ability to solve fraction equals fraction. Okay, so I think I'm done with that little concept. Really isn't any different. It really isn't. It's just a different looking picture. It's not a full, complete triangle. So, that's what ends up happening there. All right, let's give you a minute to write that down. 11, 11. Ones are wild. Oh, that just changed to 11, 12. I saw it though. So it means I'll have a lucky day. Coffee break. Delicious. How many people like Starbucks the best? Raise your hand if you drink coffee. Oh, what are you doing this for? All right. How many people like Dunkin' Donuts if they drink coffee? It's like one or the other. Oh wait, Miranda, you raised your hand twice. Is it just any coffee? You had to pick one. So which one is it? Is it Dunkin' Donuts?
If I had to pick it, definitely Dunkin' because it's more cheap too.
Oh, cheaper. Yeah, a little bit.
Yeah.
Yeah, not by too much. Yeah, I guess so. Yeah, Starbucks has the reputation of being the most expensive. So, yeah, but it's good. I like the really strong coffee flavor. I like dark roast. I like to know I'm drinking coffee, man. All right, here we go. Then the last one. This one is quite different. And this is what I mean about maybe this one, belongs on that sheet too, so that you understand the differences here. Now there is a proportionality here, but you want to kind of ignore that. Because first of all, let's talk about what a mid-segment is. That implies that D is a midpoint. So as you're drawing this and as you're writing, I know you have a lot to do as a note taker if you didn't print it. What that's saying is that is a midpoint and that is a midpoint. When you connect these two midpoints, this is called a mid-segment. A segment that's connecting the two midpoints. So first of all, knowing what a mid-segment is. Now, one thing for sure is they are parallel. So this is very similar to our theorem 2 ago, or 3. You do have these attributes, but you have more. You have more than the proportionality. Since it is a mid-segment, that's midpoints, so that cuts that into two equal parts, actually. This is equal to this, and this is equal to that because it's cut in half. That's what a midpoint is. So instead of proportions, you're going to use that. Okay, so I'm kind of stalling. You get to write the sentences here. If you want to write the stuff off to the right, that's just a breakdown of what a mid-segment does. A mid-segment of A, B, C, that's DE. DE is the mid-segment. So I don't know if you have to really write that, but, it's just denoting what we have happening here. So another thing that's in the sentence, by default, they are parallel. That's why we have those attributes that I said. So AC is parallel to DE. The segment that has the same length as BD, DA, because that is a midpoint. So these are things that you should be able to fill in, as you move forward. Mid-segment, those are midpoints, so those are equal. A segment, now here's the big thing here, and it says so right in this theorem. Mid-segment of a triangle is parallel to the third side. We already established that right here, and I'll change my colors, and is half the length of the third side of the triangle. So that means this is half of that. Remember that for who's next and who is next. Miranda, you answered the coffee question. Did you answer a math question?
Yeah.
Okay, Cecilia. All right, so remember this. AC, the segment that is half of AC, DE. All right, so remember that. I'm giving you a hint. And then the segment that is twice EC. Oh, that's a trick question. What's twice of EC? The big side, all of it, BC. From B all the way to C, because that's truly a midpoint. So be careful on answering that one. All right. So we got a smattering of questions here that we can end off with in our last 4 minutes. It's pretty simple. So Cecilia, in 5 seconds, I'll take another coffee break. That's stalling for the note takers, everyone that wants to get everything down. Okay, here we go. Cecilia, what is the measure of CD?
8.
Let's move on. That's it. It's really not a big deal. Good question, right? The reason is, and then again, all kidding aside, this is why I said about your little cheat sheet. When you get these all together, you got to say, oh, hold on. I'm looking at this drawing, and that's equal to that, and that's equal to that. So this is a mid-segment. Okay, and then you have to remember and memorize these properties of what's going on. So that is 8. All right, Jad, you're paying attention? Hey there, Jad. You got lucky too. What's AC?
8.
Let's move on. Okay, now we got some tougher questions. Genevieve. All right, again, though, all kidding aside, when you get this as a test, you're going to have a smattering of drawings all together. Everyone's got to recognize that that is a mid-segment, so we know that the relationship is double instead of half. Okay? All right. Now you got to use that, Genevieve, for this one. Oh, no. Okay, so Genevieve, let's just get rid of this real quick. What's the relationship between these two sides? You can say one of two things. One is this of the other, or one is this of the other.
zy is half of SQ.
Okay, now analyze that. And then tell me what I could write as a true equation looking at these two quantities in terms of x. You can do one of two things.
I would put x plus 2 in parentheses, so then you can multiply it by 2.
Awesome. And that's actually the smarter decision. And what does that equal? Just to make sure you're...
3x minus 8.
There you go. That's the smarter decision. Ooh, you shouldn't say smart, Mr. Samuelis. I just think it's the easier than doing this. X plus 2 equals half of 3x plus or minus 8. Because then you'll have 3 halves as a number to solve with. It's not the worst thing in the world, but both of these are true. But you don't just set them equal because they're not equal. I mean, look at them. If I get a ruler, of course those two sides aren't equal. So I think at least this should spur something that we did some notes, and I remember the half or double thing. Anyone that sets these blindly equal to each other, you're not even thinking. Not even thinking at all. It is impossible for those two to equal each other. So let's use some common sense in some of these and then move on from there. 2x, we're at 19, so 2x plus, where did we stop? Oh, David, we're going to ask you one more thing. 3x minus 8, I'm going to super flash solve for this. Subtract 2x, add 8, we get x equals 12. Let's move on. So what did we just say? What would be a true statement about this? And we'll end with you, David.
EF is half of ln.
Okay, but I need,
So then it'd be
go ahead.
X plus 4 equals x plus 10.
Say that one more time because I missed something.
2x plus 4
There you
equals
go.
x plus 10.
I missed the 2 when you said, I thought you said x plus 4. You're awesome. And then we're done for the day. So I think that's the better choice than doing half. All right, so just make sure you understand that. All right, we're good for the day. Oh, Hannah, Ryan, Gracie, Matt, we didn't get to you, and then Ethan, the V. You guys got away with one today. I'll try to remember that. Next time we meet. So the next time we meet is Tuesday. Wrong. I have to go to school Tuesday. Yay for me. Meetings all day long. Mr. Samuelis loves meetings. And then Wednesday, we'll probably do some sort of review or something. You're walking in ready for all of these things. I think a really smart thing is to make that little cheat sheet with these last couple days of things. So you recognize the drawings and then recognize what you're supposed to know from those. All right, because you're going to have a whole smattering of those questions on that quiz in one section. Ooh, sorry. I choked on my breath there. All right, we'll see you on that. We'll end on that weird note. Have a good day. I'm going to stop this video and probably chop off that last weird part that I just choked.
Mr. Samuel.